Welcome everyone to this webinar about food quality and how to reduce the food waste. Today we have very exciting presentations because not just the technical difficulties are now overcome, we had some, but also we have a guest from USA, a CEO and co-founder of ImpactVision, Abi Ramanan. Good morning, Abi.
Hello, thank you very much for having me. Really looking forward to the webinar.
Okay, so we start so that I will be presenting or warming up the talk, and then Abi will continue after my presentation. First, I will give some general advice. We are having, or if you have any questions, just write down to the chat region. We are not answering them during the presentations, but after the presentations, we will ask answer all the questions you might have. Next, we have 3 polls during our presentations, and please be kind and give some answer to those polls. They are just general questions. And finally, if you encounter any problems, usually Chrome browser is the most stable, and if you have Internet Explorer, sometimes you might have difficulties with that. That's all. So let's begin our presentations, and as I thought, I will start. How can we improve food quality and reduce waste? Something about our company first. Specim is now 24 years old. Actually, today is my 24th day at Specim exactly. Our company was established in 1995, and at the moment we are the leading manufacturer of spectral imaging devices, both portable and industrial and remote sensing use. Our portfolio is quite large, and the main reason is that depending on your application, and the presentations show a lot about these applications, you might need different wavelength range. And therefore, having instrumentation from the visible up to long wave infrared region is necessary. In most food applications or vegetation applications, the instrumentation between 400, 1000, 900, 1700 nanometers is the one that works the best. But still, we do have instrumentation for the longer wavelengths also. Now, although all the instruments here can be used for food measurements, we will concentrate to present 2 of the latest products we have. First of all, the FX series, where we have 2 instruments, the FX10, FX17, so visible, near, and near infrared spectral regions. The second type of instruments that we launched recently is the IQ camera. And the main difference is that the FX series is meant for the industry, for the conveyor belt applications where you are inside and you can control the environment. You don't need, you need a computer, separate power sources, and that's okay. But IQ camera contains everything, and it's meant to be portable. You go to a site, maybe in the field, forest, and you measure with this camera. It contains a battery, SD card. It has a computer for calculating the result on site. And the use case is totally different. And this is the first true, really portable camera that gives the result or classification result online. If you think about food applications, during the processing of the food, FX series might be the correct choice. But when you go to on-site and you want to make a decision in the field, for example, of course, IQ cameras are the correct choice in this case. I want to emphasize one thing. In most industrial applications, it's the spectral camera should and must be combined with other technologies. And therefore, I always speak about sensor fusion. As an example, if you have a 3D measurement and you know the material based on the information from spectral camera, you can calculate the value. If you include X-ray camera and spectral camera, you can look at foreign objects inside a meat sample or something. So combining instrumentation, RGB camera, spectral camera, sometimes barcode reader, X-ray. This is the future way to go with spectroscopy. The next I will show in general what are the main areas in food where the spectral camera is used. And I come from the field to the processing and then to the consumer side. So starting from the field, we usually speak about remote sensing. Precision mapping means that we apply a correct amount of water, fertilizer, pesticides in the field, and at the correct time. And this increases the productivity and actually decreases loss. Vegetation indices can be measured, and they tell us about the stress level of the plants. Today, when we go to a greenhouse, everything else is measured except the plant itself. We measure the humidity, carbon dioxide concentration, illumination, temperature, everything except the plant. And actually, IQ kind of a portable camera could be used in greenhouses very efficiently. At the moment, agriculture and precision farming is actually the largest single commercial application area, and one point where we actually could reduce the waste of food the most efficient way. When we talk about detection and identification, we want to see plant diseases and stress. We also want to look at the phenotyping possibilities. A phenotype reveals how the plant interacts with the environment. And by using phenotyping, we can actually select the best genotypes that survive in a given environment. And this kind of research and practical work is one way to actually use those seeds and those plants that can live in the surroundings where they are meant to be. Furthermore, when we measure grains and seeds, for example, we can see measure the fertility of the seeds. When we make gluten-free bread, we need to know that the grains involved do not contain gluten. If we have, for example, a greenhouse and they buy tomato seeds or whatever, they want to be sure that the fertility of the seeds is 100%. Otherwise, they have a lot of loss or waste by planting seeds that will never grow. Greenhouses are today turning more to LED lighting, and we are starting to talk about urban vertical farming. And there I see that the plant monitoring is extremely important, especially when the plants are in a very dense area and the possible diseases are spreading more efficiently. Chemical imaging is one name for the spectral imaging or spectroscopy. There we are looking at typically at moisture, fat, protein level. We look at the foreign materials and contaminants on the sample, if it is meat or nuts or whatever. We can also measure the quality of the food, aging, what materials are involved. we detect the fake, possible threats, fungus on the food. And one important point is by looking at the waste food, we can actually sort and recycle some part of the food that otherwise could be wasted. Color is very important to humans. When they pick something from a local store, apples and so on, hyperspectral imaging is extremely good in measuring the color. It is better than RGB camera. It can achieve the same level of accuracy than a human eye. And if we think about possible waste, when the consumer is picking apples or other fruit, measuring the color, measuring defects in the color before it reaches the supermarket is one way to reduce the possible waste. Main drivers to food industry are actually quite obvious. Hyperspectral imaging is based on measuring it's photography type of measurement where there is no danger. It's safe, reliable. When applied in a process line, we can get 100% inspection because it's non-contact and non-destructive method. We can have process lines where we have real-time sorting and rejecting foreign material and otherwise bad objects. And this way, everybody can accept this technology. If, for example, X-ray is applied, there is bureaucracy. You need a lot of training. It's actually not that safe. And compared to that kind of technologies, this hyperspectral imaging is more easily adapted and accepted. So what is the result we get when we take a hyperspectral image? And I have two simple examples which I want to present here. If we look at the cheese from a local supermarket and we measure it with a hyperspectral camera, this is what we see. On the left side, we look at the protein content, and you can easily see that the highest protein content is in the middle of the cheese. If we take a slice of this cheese and look at the fat content, it's the image on the right side, we see that most of the fat is in the surface of the cheese. And it's actually smaller in the middle of the cheese and larger in the outer region of the cheese. So typical hyperspectral image giving chemical information and where there is fat or protein. Next, very simple example is nut sorting, where we are looking the outer shell of the nut, which is of course not accepted. In the left side, you see the raw material. In the right side, you see classified result of nuts in a process line. And this can be, of course, used online and in a very large scale. We can achieve 2-3 meters per second conveyor belt speeds. Now, these images do not come from the camera. You need something else, and that's actually the processing software, the application software. And I will next hand this talk to Abi, so that she will talk more about how to use spectral cameras and some very interesting and exciting examples on this. And
Great.
wait,
Wonderful.
I will stop my screen, and then I will.
Excellent. Hello, everyone. Can you hear me?
I can hear you. Please go on.
Perfect. Okay, wonderful. Well, thank you, everyone. Thank you, Esko, for the introduction. My name is Abi Ramanan. I am the CEO and co-founder of ImpactVision. We are a machine learning company applying this technology combined with hyperspectral imaging in post-harvest food processing for a range of different applications. And I will talk through what some of the challenges in the food industry are, our approach to addressing them, and then also go through a number of specific examples of where we have used the FX series with food companies and real world case studies. So at a very high level, Esko has touched on some of the challenges with waste. Today, 1/3 of all the food produced in the world is wasted. So within that, there is kind of complex breakdown of where a lot of the waste happens. Some of it is actually used for secondary purposes like animal feed, etc. But a lot of research suggests that at least 50% of this happens upstream in the supply chain, so post-harvest and pre-retail or pre-food service. And this is really the section of the supply chain that we are focused on, with a view that being able to more effectively ripen, process, sort, distribute food upstream has benefits all the way down the supply chain. And also by being able to do real-time detection of contaminants, you can prevent product recalls. So that's the waste part. And then food fraud, which is broadly defined as adulteration, mislabeling, substitution of a cheaper product with a more expensive product. That's a simple definition, but you may remember the horse meat scandal that happened in Europe several years ago, or the melamine in milk powder contamination that affected some of the largest dairy companies. This type of fraud is very difficult to detect with the human eye or with traditional cameras. 2 white powders or 2 ground meats look very similar, but they do have a different chemical composition. They do reflect light differently. So this is another example of where hyperspectral imaging can play a role in providing rapid information about product authenticity as well as product quality. In terms of product recalls, foreign matter, and specifically, there is a problem in the food industry with non-magnetic contaminants. So plastic, paper, cardboard, a lot of challenges with translucent materials, and also with organic matter, insects and mice and things that get harvested with the crop itself can go unnoticed by existing systems like X-ray or metal detectors, which have their specific functions: X-ray to detect large, dense objects, and metal detectors to detect, of course, metals. And we view this as a complementary, hyperspectral imaging as a complementary solution to be able to detect small non-magnetic contaminants and translucent materials. And there were 30 high-profile product recalls related to foreign objects in 2018 alone, with some of the largest food brands in the world involved. So not only does this result in waste, it can result in brand damage, which can be hard to recover from. So we've developed a solution that can do real-time detection of contaminants, and I can talk more about that later. So really, I've been to, and our team have been to, hundreds of distribution centers and food processing facilities and produce pack houses. And really, the way that food quality is assessed today is through destructive sample-based testing in the vast majority of cases. So people stand by the side of the conveyor belt and look for contaminants, or use manual sorting, or test a tiny fraction of samples using an invasive pH measurement or a destructive shear force test. And all of this means that there is a huge amount of inefficiency in the way that food is distributed. We are harboring under a myth that we need to increase food production. We actually need to decrease food production by at least 50% and feed a rising population, which is going to reach close to 10 billion by 2050. So we really need to find ways to more effectively distribute and process food through the supply chain. And that's where hyperspectral imaging can really play a role, because you're facilitating a fundamental shift from sample-based testing to 100% product coverage. And there are a number of benefits that come with that. And it has just been impossible to efficiently manage complex supply chains until recently, due to the fact that hyperspectral cameras were large and very costly. The computation required to do real-time transmission of these images just wasn't available. And food companies need you to be able to meet, if not exceed, their throughput. So a number of these trends have converged, meaning that for the first time in the last couple of years, it's been possible to integrate this technology in line and really build on the foundation of spectroscopy. So as I mentioned, ImpactVision is a machine learning company. We're applying advanced imaging or hyperspectral technology to food supply chains, and we build the application software like Esko mentioned. So Specim are a great partner for us because our desire is not to go into manufacturing hardware. There are a number of hyperspectral imaging providers developing hardware, but when we started this company, no one had really identified the opportunity around the machine learning analytics layer. So our application software develops custom software for applications like the freshness of fish, the dry matter content of avocados, or the presence of foreign objects. And of course, the main advantages of hyperspectral imaging are that it is non-invasive. So you can, as I mentioned, shift away from doing sample-based testing to fully automating quality control with an inline system providing 100% product coverage. So effectively, it's a tool for digitizing and automating quality control and really helping the food industry to move away from using these analog measurements. So our solution essentially combines hyperspectral imaging with machine learning, and we use these techniques to try and understand the chemical composition or the internal quality of food products. And the goal is that this will allow food companies to understand almost 100 times more information than they've previously been able to. And taking a sample-based test and applying a statistical model has its limitations. If you take even avocados harvested from the same tree, for example, can have a different physiology. And there can be a lot of challenges when you're sourcing from different countries of origin, or when you have huge volumes, and there can be variance in dry matter. And I'll come on to talk about dry matter and the importance of it for the avocado industry. So the goal of this technology is by implementing it in line, every single product can be sorted or ripened or detected or processed based on its unique chemical composition. And based on this, for the same amount of input, you can really improve yields by delivering more in-specification product to the end user. You can prevent product recalls by detecting contaminants in real time and not waiting for a consumer to find them in the finished product. And you can also really reduce waste. So to take an example of in-store waste in relation to meat products, there are a lot of challenges with out of specification product arriving at the retail level. But by the time the product is packaged and on the shelf, it's too late. All that can really be done is a price reduction. Whereas if the end product form can be optimized at the distribution center itself, then it gives a significant amount of time by which to utilize that product best according to its composition. And also what this allows is tighter product specifications and then objective information at every stage of the supply chain. Today, a retailer can reject 10 tons of product based on a sample-based test, whereas with this technology in the future, a producer can say, you know, we've got data on every single product and we can verify the quality. So it's about introducing more rigor into the supply chain about how food is assessed. So our product, as you can see here, this is the hardware, and this is a product that we have deployed in Mexico with a company called Beta San Miguel. They are Mexico's largest sugar processor, and this is a system for detecting non-magnetic contaminants during the repackaging process of refined sugar. So we have used two cameras, the FX10, which is the visible, predominantly in the visible, and then the FX17 visible and near infrared. And the near infrared camera is specifically for detecting translucent materials, which are not visible in the visible spectrum. So we mount the cameras over the conveyor belt. We acquire the hyperspectral images based on how the products are reflecting light. Our machine learning models interpret these images in real time and send back instant insights on quality parameters like freshness, shelf life, or contamination. And the solution has been designed specifically for industrial high throughput environments, companies that are repackaging 300,000 tons of sugar in several months or distributing over 1 billion avocados. So the equipment needs to be very robust. And as a result, we have worked with a automotive car manufacturer to develop casing that meets FDA regulation for food processing facilities. And another really critical requirement, and I alluded to this earlier, is around production grade speed. So typically conveyor belts are moving anywhere from 28 to 40 inches a second, which is about 73 to 120 centimeters a second, and significantly higher than that. So one big area of our work and our development is on maintaining accuracy at high throughput production grade speeds. And then once the technology is implemented, the goal is really to help food companies have much better visibility into the products that are passing through their distribution centers, maximizing yields, and also delivering consistently high quality products to consumers. There is, and rightly so, a greater demand for consumers for transparency, for information about provenance, for information about quality. So for food brands, and particularly some of the companies that we work with, investing in this technology is a way for them to position themselves as premium. And that is valuable in today's kind of highly commoditized industry. And this is just a screenshot of our website. If you're interested in finding out more about this product for foreign object detection, then you can just go to www.impactvi.com. And as soon as you land, you'll see a video and you'll be able to understand more information about how this product is operating in Mexico. And it's also worth stating that another good advantage of hyperspectral imaging, and something that we communicate to food companies, is that once you install the hardware platform, if you start off with a product for foreign object detection and then you decide you want to assess moisture content or you want to assess an element of color, without making significant upgrades to the hardware, we can add additional software modules. So it sort of replaces a whole range of different sample-based tests, not just one. And just a little bit more information about foreign object detection. As you can see in the image of sugar with foreign objects, there is plastic, including from a packing bag underneath the surface of the sugar. If you look at it for a while, you can start to make out the shapes. But if this was moving at high speed, it's just not what human eyes have been designed for. And the way that we conduct, or the way that we build the software, is we detect and classify objects by grouping pixels which have similar spectral profiles together. And once a certain threshold has been reached, then the object is classified as a contaminant. This again is a picture of the hardware setup in Mexico. Another advantage of not manufacturing hardware and instead working with leading providers like Specim is that the solution becomes very modular. We can take the hyperspectral cameras from Specim, we can source the illumination units, and we've designed our own modular aluminium rig. But this really is a solution that's designed to be retrofitted in existing production facilities. So it doesn't require, in theory, it doesn't require extensive investment in additional supply chain infrastructure. There are, of course, some nuances with that. In Mexico, for example, the construction was built from scratch because previously the repackaging process was entirely manual. But the goal, and certainly with other companies that we are speaking with and have carried out pilots with, it's to retrofit this solution on existing conveyor belts and integrate with either sorting infrastructure or rejection infrastructure that already is in place. Just a little bit of information about the user journey. So if we take the avocado example, the system is installed in line. We acquire the hyperspectral images, we apply machine learning models, we generate real-time food quality insights, and then crucially, we integrate with the sorting and rejection equipment. Half of the value provided is the insight that is generated, but the other half is ensuring that the food company, that the customer can act based on that information. And that's where the sorting or the rejection component becomes critical. It's designed to be a very low touch product. So once it's installed, we take care of the software upgrades and the installation, and we provide a manual which includes information about how to clean the lenses and replace the bulbs. But the goal of the product is it's supposed to be autonomous. Another way that we are using the Specim camera and hyperspectral imaging in general is through the use of the benchtop system. So there are a number of food companies, meal kit delivery companies, berry distributors who typically only process blueberries on conveyor belts. Other berries are packed in the field and then brought into the distribution center on pallets. So these companies don't have conveyor belt infrastructure, and they don't have a need, or at least a big enough need to install it. However, they would still like the opportunity to do a higher rate of non-destructive sample-based testing. For example, today in a distribution center for produce, shelf life is typically assessed visually. So this can fluctuate a lot between who the inspector that is doing the visual inspection. It introduces a lot of subjectivity, and it isn't a very accurate measurement. As a result, we are working with a couple of different companies on being able to provide them the benchtop system with the integrated with the software as a standalone product, so that they can scan samples, and with salad, for example, they would get a reading of shelf life to plus or minus 1 day, and then they would also get an accept reject criteria. So starting to bring a lot more objectivity and automate their inbound QC inspection. Similarly, for berry companies who might be interested in understanding bricks quality, which is an application that we are currently exploring, and I can talk about some of the other applications when I get onto the FX series. they would be interested in doing a higher rate of sample-based testing as well. So this is just another way in which this product can create value for food companies. This shows the first version of an interface for our dry matter solution. So dry matter is a very critical parameter in the avocado industry for understanding how long an avocado should be ripened. It really helps to inform avocado ripening regimes. The problem is that today, in order to understand dry matter, you have to cut an avocado open, put it in a laboratory oven, weigh it for cook it for a couple of hours, take it out, weigh it again, and then perform an equation to calculate the dry matter. So it's very laborious. Only a tiny fraction, somewhere in the region of 0.1 to 2% of samples are tested. There are also spectroscopy tools that can do dry matter analysis, but the error margin often is in the 5 to and sometimes as high as 8% region, which means that there are challenges with the reading, but also it's not possible to use that as an inline tool. Ultimately, what will be most valuable is having a dry matter solution, or at least as valuable, having an accurate dry matter solution, an accurate solution for reading dry matter in the field. But I think that the true miniaturization of the sensor still has a couple of years of development to go. So our goal with this product is to replace the laboratory oven method eventually by installing this technology in line. So you have a 2 or 4 or even 6 or 10 lane sizer. Hyperspectral cameras are integrated and avocados are then sorted based on the dry matter value. And as a result, you have buckets with much lower variance. You can ripen more consistently, deliver more in specification product to food service and to retail, and really help to improve both the quality delivered and the yield of the original input. So we are a post-harvest company. We sit in the section of the supply chain that's pre-retail, pre-food service, and really we are optimizing activity at the distribution center, at the produce packing facility. If you imagine high volume, high throughput, very fast moving environments with lots of products passing by on the conveyor belt, that's where we can most effectively create value. The business case for food companies falls broadly into 4 areas. So you can, and I'll talk in more detail about these applications. You can increase quality by measuring parameters like tenderness or shelf life or intramuscular fat. You can prevent product recalls by doing real-time non-magnetic and magnetic, but the speciality is in the non-magnetic foreign object detection. You can assess dry matter, which is correlated with ripeness, so really helping to reduce waste. And also fraud. So we talked about this a little bit earlier. So the fish industry is one of the most fraudulent industries in the world. And food fraud in general has risen by 2/3 since 2010 and has become such a problem that the UK has established the National Food Crime Unit specifically dedicated to dealing with this type of fraud. And I think that I read somewhere that now every shipment of olive oil that comes into the US has to be checked for authenticity. Agar honey is another example. 1 ton is produced, 9 tons are sold. So there is clearly some kind of discrepancy going on with adulteration there. And with relation to fish, so if you have been to the US and ordered red snapper, there is an overwhelming chance, almost 90% likelihood, that you have in fact been served tilapia. So substitution, particularly of filleted fish in the fish industry, is a huge problem. Again, for the human eye, being able to tell the difference between 2 pinkish fillets of fish, it's challenging, unless you are a very trained inspector in quality control, which does work, but it's just not a particularly scalable model. So we think that there is a lot of potential to do product authenticity in the fish industry in particular. And this type of fraud is having huge implications for everything from depleting fish stocks in the ocean to a rise in seafood allergies, as well as the economic impacts. So interspecies classification is one area. And then there is also the ability to detect freshness. And we worked with a Spanish fishing cooperative in the northwest of Spain last year. So I'll talk more about that when we get to that. Okay, so now getting on to why hyperspectral imaging and food and the FX series application examples that we've been working on for about 2.5 years. So the applications that we've worked on and developed include beef shelf life, pH and color, beef tenderness, foreign object detection, fish freshness, dry matter content of avocados, shelf life of salad, including leafy greens like spring mix and spinach. And future applications that we're developing include apple firmness, bricks content of berries, and dry matter content of potatoes. So these are all applications we're discussing with various food industry partners. So first, talking about beef pH and color. So we worked with one of the largest retailers in the US, and they were experiencing challenges with high levels of in-store waste. In addition to this, a number of retailers, Tesco being a great example, have made commitments to reduce waste, Tesco in particular, to reduce waste by 50% by 2030. So the challenge now for companies that have made commitments is finding the appropriate tools to measure, track, predict, and then prevent. And that's, again, where hyperspectral imaging can play a role. So we worked with this retailer on 2 different varieties of steak and used pH and color as a proxy for predicting shelf life. So firstly, this approach is much faster. Using the benchtop system, it took about 4 seconds to get a pH reading, and a pH meter takes about 2 minutes, 30 seconds. Secondly, we found for one of the brands of steak that a quarter had a pH of above 5.9. Meat, which has a pH, particularly steak, which has a pH of 5.9 or higher, has a significantly larger risk of being rejected by a consumer. It will become something known as DFD, dark, firm, dry, much faster, and will eventually end up as out of code or reduced to clear product. So either creating no value or dramatically reduced value. The goal of this technology was to implement it, eventually to implement it in line, so that as meat is passing by on a conveyor belt, it can be classified based on pH and color. And if it has a high pH, it can be turned into a secondary product like ground beef or mince. It doesn't need to be wasted. It's just this information needs to be known earlier on in the supply chain. And longer term, a high pH indicates a problem with the supplier. So it again also allows different actors in the supply chain to have a much better understanding and visibility into their supply chain so that they can rectify whatever issues may be causing a high pH, for example. Beef tenderness. So we worked with a European beef producer to develop an initial software application for understanding tenderness. So today, again, you'll probably see a common theme emerging in how quality is assessed today. So tenderness today is assessed using a measurement called the Warner-Bratzler shear force test, which essentially is a knife that you press down on a piece of meat and then calculate the pressure in newtons. The threshold generally of what is desired for tender meat is around 40 newtons. So we worked on trying to match the 40 Newton threshold with an error margin of around 5 newtons either side, with the goal of being able to allow beef producers to increase the volume of high quality meat they sell to their premium clients. So improving yields as well as increasing revenue. So this notion, the food industry has very slim margins. So there are 2 ways to address this: cutting costs. Costs are already quite low, or increasing revenue through delivering premium products and developing additional ranges even to satisfy premium clients. And this is more where hyperspectral imaging fits in due to the ability to segment based on quality all products. There is just a much better understanding of how premium ranges can be developed. But this project was also a good learning in terms of the quality of the ground truth measurement will always dictate the accuracy of the algorithm. And the Warner-Bratzler shear force test has a number of challenges as a ground truth measurement itself. So if the reference measurement isn't providing an accurate reading, the hyperspectral imaging system cannot beat that. So just good to be aware of how important the ground truth or the reference measurement is. Fish freshness. So we worked with a Spanish fishing cooperative, as I mentioned, in Galicia. Initially, we worked with hake fish, so to classify the freshness of hake using the skin and the scales. So today, a human quality control inspector will look at the eyes, the skin, and the gills and use this to determine the freshness. In the European Union, freshness is classified by the European Commission in 3 categories. Well, actually 4. So extra, which is the best, A, B, and non-admitted. But the goal is obviously to really reduce the amount that is not admitted, because that cannot be sold. We found that the skin and the scales were the best predictor of freshness for the purposes of this study. And for this particular company, they represented many large fishing vessels. They felt that they were quite distant from the end consumer. And again, they had this real desire to start positioning themselves and their brand and their product as premium. And they wanted to use this technology as a way to communicate information about quality more effectively to the consumer. So we talked about how in the future, maybe there could be a sticker or a stamp on the products that they provide saying it's been classified as premium quality. And this brings me on to the point of standardization, which if you take fair trade, for example, where I used to work, it took 15, 20 years for fair trade to be recognized as a legitimate standard by the consumer that was delivering a fairer income to producers in developing countries. Standardization takes time, but ultimately we feel that hyperspectral imaging will become a new standard for the way that food is classified, and the confusion around use by dates and sell by dates and best by dates is one of the drivers of at least waste on a household level. So having a standardized, more objective way of actually verifying food longer term, I think, is the goal. And for that, we really look to work in coalition with other hyperspectral imaging providers, other software companies, other hardware companies, because ultimately a standard is developed by an industry as a whole in collaboration. So dry matter content of avocados, you can see on the right-hand side, us doing the imaging campaign at a customer's facility last year. So I've talked a little bit about the importance of dry matter, but it's a crucial quality parameter for determining avocado ripening regimes. And today, really, the industry standard is the destructive laboratory oven method, and only a fraction of samples can be tested. The goal is for us to deploy this system inline so that avocados can be sorted based on dry matter. And avocados have a particularly unique physiology. They, once they're harvested, they ripen or they mature very rapidly. So you have a limited amount of time by which to optimize the use of the product. And today, a food service company, a very large one, can source anywhere between 50 to 250 million avocados annually. And the waste percentages can be quite high, 5, 10, 15, 20, even 25%, if there is a lot of inconsistency in ripening and therefore out of specification product arrives. Particularly for food service, they're looking for that ready to eat quality that can be turned into guacamole and these other types of products. So reducing waste through delivering a more consistent ripening process is a really valuable use of this technology. And dry matter is actually one of the unifying parameters of all the distributors, processing facilities, ripening facilities, exporters, wholesalers of avocados in particular that we've spoken to. Dry matter is one of the most critical quality parameters for ripening. And as Hass has grown in dominance, 90% of what is exported now to countries like the US and Europe is Hass. So there are still, of course, challenges because everything, the environmental conditions, the amount of sunlight, etc., can affect it. But for a food product which is organic, this is as standardized as I think it's possible to get. Talking a little bit more about foreign object detection. So we've launched, and that will go into production soon, the system for detecting contaminants in sugar, but we've also worked on detecting contaminants in potatoes, in raisins, in products like cookie dough, in produce, and in meat. So as you can see here in the image on the left, the ground pork is moving at a conveyor belt speed of around 12 inches a second, and a piece of black plastic is underneath the surface of the ground pork. So we really specialize in detecting small non-magnetic contaminants. And on the right-hand side, we've detected the plastic and it's marked with a red dot. And this really is achieved, again, by kind of classifying and color coding the pixels. By having access to the spectral data set and not just the spatial, you're able to do a more sophisticated analysis of contaminants. In terms of customer testimonials, so we have been very fortunate and also worked very hard to build strong relationships with the food industry. We won a competition last year organized by Tesco to work with their suppliers. We're working with Mexico's largest sugar processor. We took part in a program with Chipotle, and we have partnerships with a number of other food companies as well. So it cannot be overstated enough how important it is to build relationships in the food industry. Trust is extremely important, and to be solving a very critical problem where the ROI can be realized in a 12 to 24 month period. Because you are working with such slim margins, it means that the emphasis on solving very critical problems is very, very, very significant. And this really is the future. So I'm sure that Specim will be announcing, no, I'm just joking. But really the way that the technology is going is that the hyperspectral sensors continue to miniaturize. There are a number of commercial ventures, research institutes, etc., that are working on using various different techniques. Some are working on tunable filters, some are working on other methods to create hyperspectral capabilities in a miniaturized format so that the camera module can actually be integrated into a smartphone. And this, I think, at this point, you reach the stage where hyperspectral imaging could become as prominent as GPS was for navigation by allowing a whole new world of applications within food. And also there are a number of companies working on, for example, doing non-invasive scanning of the retina to understand predisposition to certain diseases and manuscript detection. But for the food industry, when the technology miniaturizes, it would allow a whole new range of applications. You can take it onto commercial fishing vessels, you can take it out into the field, you can use it at point of sale. So, and of course, consumers will also have access to it. So you can walk into a supermarket and take a photo of an avocado and know how many days until it's ripe, or take an image of a fillet of fish and know the species. So really exciting potential for the technology. Our goal is predominantly to work in industry. We think that particularly for the environmental mission that we have around reducing waste and really improving the yields of food systems, of food supply chains, to ensure that they are kind of resilient and helping the food industry to also meet its climate change obligations. We think that the industrial route is the best one, but we very eagerly track and partner with companies that are working on the miniaturized sensor, because like I say, then you just open up by orders of magnitude the number of companies that can work with this technology. And as I mentioned, we've worked with and are supported by some of the leading food and agriculture investors, food companies, including Tesco and Unilever, Chipotle, and as well as organizations like the World Economic Forum. And this has been really helpful in helping us to build our network and grow the number of potential companies that we could work with. So that's the end of my section of the webinar. I really hope that you have found it interesting. Please feel free to get in touch with me if you have any questions about the presentation, about hyperspectral imaging, about other applications you think that we should be working on. The details are at the bottom of the screen, but my email address is abi@impactvi.com, and you can, of course, get in touch with me directly as well. Thank you very much for listening, and thank you to Specim for hosting.
Okay, thank you, Abi. Very, very interesting and amazing talk. Please stay on the line.
I will.
Because we do have a few questions, some of which are for you. But I will start from the first one, which was by John Taylor. And he was asking about the protein fat mapping that I was showing. The classification tools that are used by us and others are usually, or actually always, referenced to some laboratory instruments. So the fat protein is the reference data comes from the laboratory, and then it can be applied to, for example, online applications. Then there is a question from Jordan Roberts, and he's asking, what is the minimum size of foreign material that can be detected? There are a huge amount of different aspects that are involved, and there is no single answer. If you have an application and you could send me some parameters, then it might be easier to answer this question just based on this information.
And I can just add to that question that it really depends on the width of the belt, the throughput, and the resolution. I would say we'd be with one camera, either the FX10 or the FX17, and approximate with a 48-inch belt, you'd be looking at around 5 millimeters as the smallest detection size. It's possible to detect much smaller. For example, in our lab, we can detect even 0.5 millimeters. But of course, the camera is much closer to the belt. So it really depends on the configuration of the facility. But like Esko said, if you're able to share some parameters, then one of us can get back to you.
Exactly. Thank you. Then there's a question from Rosen Angelov. Is this technology fast enough to be able to scan tomatoes in a production line? And I think Abi also knows the answer here.
I'm not sure I know the exact answer. I do know that tomato lines go very fast. It depends if you're looking for a quality parameter. In fact, we just saw a video from a potential customer where it was about 500 feet a minute the line was going, and that was extremely fast. It depends what kind of parameter you want to assess, what the width of the belt is and what the throughput is. But if you're able to just share some initial information, I can definitely speak to the team and get back to you.
Yeah. Then we have okay, this is for Abi. What is typically the percentage of contamination in sugar? Is there a clear answer to this question? Is it something that is difficult to?
It is a little bit difficult because that system, we've done a number of production runs, but it has not yet fully gone into production. Generally, there are incidents prior to the system being installed that happen on a weekly basis. Not all of them are critical, and often the objects are actually detected, and it really varies industry to industry. For a potato processor, for example, they may have 2 to 3 incidents a year, but they can be very costly because if a product goes through, it damages the blade needs to be replaced, and the whole batch needs to be recalled and replaced to the customer. So the frequency of the recall is one factor, but also the damage that can be caused can be greater from fewer recalls if they are more significant.
The next question is also for Abi. Tim Hullebrook asked, what was the material of the protective glass and halogen illumination so that it meets FDA regulations? Is this proprietary information? Are you willing to share that information, Abi?
Yes, I'm happy to share the information. It probably is best if you contact me afterwards, because we worked with an independent manufacturer to build the casing, and they were developing equipment for the automotive industry. It's IP65 casing, and if you have more information I can share, or if you require more information, I can share that with you. So please just get in touch via email.
Okay. Then Lucas Cesaris asked, do you find some challenges in terms of spectral and spatial resolution while measuring specific product? This is again rather general questions. Of course, there are challenges, especially spatial challenges, if we are trying to find a very small object or foreign material. Usually when we are talking about food, I don't see that we have challenges in spectral resolution because the absorption lines and features, they are quite broad. So the spectral region is usually not a problem, but spatially, what is the smallest detectable object? That might be a challenge in some cases. How do you comment?
Yes,
Abi?
I mean, with hyperspectral imaging, the spatial resolution is a challenge. And like you said, Esko, the approach may be to use a combination of technologies. So an RGB plus NIR camera, which has much greater resolution for certain applications. It is a challenge. We, for example, today cannot detect a single hair using hyperspectral imaging, and there are demands for a single hair or a single matte fiber, for example. So I think one solution is to augment with other camera technologies.
Next question is something that is new to me. Lucas Cesaris asked also that have you used hyperspectral imaging for GMO products, so gene, how do you say that, gene manipulate or GMO?
Genetically modified.
Yeah, genetically modified. Do you know any applications, Abi? I don't
know.
No,
we haven't. I think because of course the whole technology is based on light, and generally either you have the reference ground truth measurement or you are based on kind of imaging based on an existing categorization that has been put in place. For example, the extra, AB, and non-admitted. I'm not aware of a way to do a reference measurement for GMO. So we have not worked with that so far. So
no information on that. Jessica Butenhoff asks, how long does it take for ImpactVision to develop a solution for a new food product? For example, if we're talking about freshness.
The first pilot that we ever did, it took about 3 weeks because we needed to acquire each individual pH meter measurement, colorimeter, and the hyperspectral images. We have since become a bit smarter in the process and really refined the imaging campaign. Now we work with food industry partners to actually do the ground truthing. We cannot become domain experts in the shear force test, the laboratory oven method, the pH meter is not too bad, but the refractor meter, etc. So we've now refined the process to about 2 to 3 days. For foreign object detection, it's much faster, about a day. We typically ask the company, please send us samples of the product and the foreign objects. And because we have done so many of those, we can do the imaging campaign in half a day or a day. For a brand new product, if we took dry matter content or soluble solids of tomatoes, for example, we would partner with the company, ask them to do the ground truth measurements, and we could complete the imaging campaign in 2 to 3 days. And then it would take 2 to 3 weeks to build the model.
Okay. Abi, you showed the beef scanning, and there is a question: was it already packaged? So was it inside package, or because in the image I think that it was packaged already?
So the image was more to show the waste that was happening at the supermarket level. So that was all product that had been taken off the shelf and was going into landfill. We try very much to avoid discussions of working with packaged products. There are some plastics that can work, but of course you absorb a significant amount of light, so you don't get with the packaging, you don't get as strong a signal back. So we generally try and work with exposed product. Yeah.
Then there is a commercial question: what is the cost of this solution? I would urge people Campbell to contact Abi directly with this question, because I'm sure you need a little more information, Abi, to answer this kind of questions. So
yes, I would encourage you to contact me directly. It really varies, again, depending on the width of the conveyor belt, the throughput, because that will affect the illumination and the complexity of the application itself. So please get in touch with me directly and we can have a discussion.
Okay. Ran Pelta asks about machine learning tools that are used. This is again quite broad question, because I know that Python, C, R, there are a lot of languages that are used, and I'm not sure what you are using, Abi.
We are using a range of different machine learning techniques depending on what the application is. So a lot of the more standard tools support vector machines, etc. And then we also use TensorFlow and convoluted neural networks, and a range of different techniques depending on the application.
Yeah, I agree on that. So there is no single tool. No single language, or there are libraries in many languages already developed. So
yeah, exactly.
Raj Shah has a question about how critical is the lighting system and its calibration.
Excellent question. Obviously, lighting is extremely critical. We have discovered that because we work unlike with precision agriculture, where you also have to deal with a moving environment and cloud cover and obstruction from birds and things like that, because we are working in very controlled environments, distribution centers, the lighting itself is fine. Initially, we used to carry out imaging campaigns in rooms with darkened windows, and we've realized that with the halogen illumination unit, the lighting can be controlled. And in terms of recalibration, there will be some recalibration of the illumination unit that is required, but we provide all the information about this in the operator manual that we provide with the systems.
Okay, thank you, Abi. Unfortunately, our time is up, and I really appreciate your time and effort, Abi, and the excellent examples you had.
Thank you. Well, it's been a pleasure to work with you so far. So thank you very much for organizing the webinar, and I look forward to speaking with you again soon. And thank you everyone for listening.
Okay, thank you. That's
Goodbye.
also bye from me.